This is a test covering exponents, radicals, and polynomials. So if you're watching this video, it might be that you didn't do very well on the test and you're studying to do some recovery. So make sure you're not just copying off of me. You should not have a pencil in your hand. You should watch and learn how to do these problems, but then try to go back and do the problems by yourself. Okay, let's get started. Okay, which of the following is a rational number? Alright, if it's going to be a rational number, technically a rational number is a number that can be written as a fraction. Alright, a fraction of integers. Okay, like -2/3 or even 5/1. Even 0/7. All of these would be fractions of integers. So technically any rational number can be written as a fraction of integers. Having 0.7/3, this is not an integer, so this writing as a fraction like this doesn't count. Alright, now, however, it's not always obvious at first glance whether or not something can be written as a fraction of integers. So it's useful to realize that if we're looking at a decimal, if we're talking about decimals, okay, again, if it's going to be a rational number, it'll be rational if it either ends or repeats. Alright? Rational numbers end or repeat. So, if there's a number that doesn't end and doesn't repeat, then that's going to be irrational. So it's not going to be A because of pi. Pi does not end and it does not repeat. So that's irrational. Okay? This one, 6 radical 8. Focus on the radical 8 part. This is irrational. Alright, if it was going to be rational, this would have needed to be a perfect square, like square root of 9, because that's just 3. Or a square root of 25, because that's just 5. But square root of 8 is not a perfect square, so, you know, if you were to put this in your calculator, and, well, I'll just start with square root of 8. Square root of 8. Okay, well that's 2 radical 2, but if I hit this toggle button, you see it's 2.828427125, and that's just where the calculator ran out of digits. It would keep going and going and going forever without repeating, just like pi. Okay, so that's irrational. So that's not it. Okay, what else you got? I need something that either ends or repeats. Well, it can't be C either for the same reason. Square root of 3, that's not a perfect square. But D is okay because the square root of 16 is 4. So this is really just 4 times 4, which is just 16. By the way, I want you to get comfortable with using your calculator to check what's going on. Your calculator will handle square roots very easily. So if you had any question about it, you might have just typed this into your calculator like this, 4 radical 16. And you would see that that's just 16. So that is a rational number. So the answer is D. Let me just make it look better. And it's D because this, as a decimal, ends. Alright, now this one. Now I'm going to show you how to do this by hand. But, you know, I mean, this is multiple choice. You have no excuse for getting this problem wrong when you consider the fact that your calculator will do this problem for you. And you all had calculators in your hand when you took this test. So I just don't understand anybody who got this problem wrong. So we have 3 radical 11 squared. So just first off, let's just go ahead and type this into our calculator. Open parentheses, 3, and then there's our square root, 11. Get out from under there, close the parentheses, and that whole thing is squared. So I just typed it in. Oh, look at that, 99 is the answer. Okay, so this was multiple choice, so the answer is C. So anybody that got this problem wrong, I'm hoping you can see that your calculator is your best friend, and I really want you to use it. You know, even if you think your answer is right, check it. Now, here's how you're meant to do it. You know, so here's where I put my teacher hat on, and I want you to be able to do everything, you know, by yourself without a calculator if you can. If you're squaring an expression like this, then the idea is, so here's our 3 radical 11. I'm just spacing it out a little bit. But I'm squaring this, so that means I have to square both of these things. So 3 squared is 9. Now, radical 11 squared, an exponent of 2, you know, if you square something and take the square root, they just cancel each other out. So that's just 11, all right? Because the radical and the square, they undo each other. Those are inverses. So it's just 9 times 11, and that's why it's 99. Okay, let me quiz you on what I just told you, though. If I said, what's the square root of 147 squared? Would you know what the answer was? Say it out loud. I'm hoping you just said 147, because the radical and the exponent would cancel each other out. Okay, but that's neither here nor there. Let's move on to number 3. Okay, the calculator wouldn't help you with this one, but luckily almost everybody got it right. When we learned about fractional exponents or rational exponents, we learned that it meant power over root. Alright, it's always power over root. So here, when I have x to the 5/3 power, 5 is the power, and 3 is the root. Okay, so that's B. B is the one that has 5 as the power and the cube root. So the answer was B. Alright, looking at number 4, which expression is equivalent to this? Now, your calculator will not simplify cube roots for you. I will show you how you can check your answer, though. But first, let me show you how to, this one you really need to be able to do on your own. We're talking cube root here, not square root. Alright, if it were square root, the answer would just be 4. But this is cube root, so the answer is not 4. We need to look for a perfect cube that divides into 16. Here are some perfect cubes. 1 to the 3rd power is 1. Alright, but that's not going to be useful to simplify. 2 to the 3rd power is 8. 3 to the 3rd power is 27. 4 to the 3rd power is 64. And 5 to the 3rd power is 125. Well, other than 1, only one of these numbers is even smaller than 16. Luckily, it's the one that we need. Alright, so 8 is the perfect cube here. And 8 divides evenly into 16. So we can take our cube root of 16 and split it up. 16 is 8 times 2. Alright, so I'll put the perfect cube in red so it stands out and you can follow it. So if you ignore the times 2 part, I've got the cube root of 8. What's the cube root of 8, guys? The cube root of 8 is 2, since 2 is where it came from. So that's why this is going to become just plain old ordinary 2. Not cube root of 2, just 2. Alright, now the blue part just stays the way it is. I've got the cube root of 2, so this is going to stay cube root of 2. So I have 2 cube root of 2. So that's the answer. So that's why the answer to this one was D. 2 cube root of 2. Alright. This was a very frequently missed problem. Not as bad as number 5, but it was right up there. Okay, now, the calculator won't just give you 2 radical 2, but let me mention something about the calculator as far as checking your answers. You know, because if you take an end of course test, when you take the end of course test, there will be a lot of multiple choice questions. Okay, let's start with the cube root of 16. Here's how you type that in your calculator. If you want the cube root, first you type the 3. And then you see this function right here, it's the x root. You will use that function. So second caret, now it's the cube root. Cube root of 16, enter. Alright, so I get this decimal. I'll just write down the first few digits, 2.519. Okay, so as a decimal, this is approximately, alright, 2.519. So that's the value. So right away, you know that it can't be B, alright, because that's not 2.519. It can't be C. So it can only be A or D. Those are the only possibilities. Let's say if you were leaning towards A. Alright, I'm going to go ahead and say that that's a little silly to even be tempted, because this is cube root. So how is it going to change from cube root to square root? You know, we've never seen that before in life. So that was a silly guess on your part. But say if you did, for some strange reason. If you put that in your calculator, 2 square root 2. Alright, you're going to have to hit the toggle button here to get the decimal version. So that's 2.828. Okay, 2.828 is not 2.519. So you know that's not right. So that just leaves you with D. Okay, now let's test that one out. So D is 2 cube root 2. So let's do 2, and then I better do times. Now for the cube root, I have to do 3, and then I'll have to hit second caret. So there's cube root 2. So 2 times the cube root of 2. If I hit enter, oh, look at that, 2.519. 2.519. So the decimals, because this is approximately 2.519. So even though the calculator wouldn't do it for you, because it's multiple choice, you can convert the answers into decimals and see which one matches that way. Okay, so that's just another strategy you can use if you can't figure it out properly the way I showed you in the first place. Okay, and number 5. This was the most commonly missed problem, and it is a little bit tricky. So first you have to understand about perimeter. So let me start with that. What is perimeter? Well, if you look at a rectangle, alright, here's a rectangle. If I told you that this was 5 and this was 10, could you tell me the perimeter of that rectangle? Well, hopefully you're saying, okay, well if that's 10, then this is 10. If that's 5, then this is 5. The perimeter is the distance all the way around, so the sum of all the edges. So that's 20 and 10, so that's 30. So the perimeter would be 30 for this made up problem. Now let's put some variables in here. Okay, we've got length and width, alright? So say if this is the length and this is the width. Could you give me an expression for the perimeter? Well, like we did with the numbers, if this is a length L, then this will be the same length. If this is W, then this will be W. So the perimeter would be like length plus width plus width, sum of all 4 sides. Well, these two are the same, right? So the perimeter is equal to 2L plus 2W, double the length plus double the width. That should give you the perimeter. Now I'm setting it up this way because it'll be a lot easier to work with these L's and W's than it will be to work with all of these complicated trinomials. So they gave us the perimeter. All right, the perimeter is known, at least an expression for it. And they gave us the length. The length is 3x squared plus x plus 8. They gave us the perimeter and the length, but they want to know the width. Okay, we're supposed to find an expression for the width. So in other words, look guys, we need to solve for W. So if I were you, I would solve for W using this equation, and then just plug all those ugly expressions back in at the end. I think that's the quickest thing. Okay, so solving for W. So the first thing you would do is you would subtract 2L from both sides. Okay, that way these cancel out. Now, these aren't like terms or anything, so I just write P minus 2L like that. And so that's equal to 2W. Now, if I want to get W by itself right now, what am I going to do? I need to divide both sides by 2. Okay, so I'm going to divide by 2, divide by 2. Okay, so this is an expression for W. In fact, I hope you don't mind if I flip it around the other way. So we now know that the width is equal to the perimeter minus 2 times the length, but all of that has to be divided by 2. Okay, so now they gave us an expression for the perimeter and an expression for the length. So I say we just substitute all that in. Alright, so they say the perimeter is 8x squared plus 6x plus 22. Okay, so I'm going to go ahead and substitute that in. I already forgot it. 8x squared plus 6x plus 22. Okay, I'm just putting that in right here for the perimeter. Now I have minus 2 times the length. Alright, notice anytime I substitute for a variable, I use parentheses. So the length is 3x squared plus x plus 8. Alright, so you see I'm doing perimeter minus 2 times the length. So here's the perimeter minus 2 times the length. So you use parentheses. Now all of this is eventually going to be divided by 2. Okay, because that's what we found. So all we really have to do is simplify this, and we're golden. Now this first part, because it's positive, there's nothing in front of these parentheses, I can really just erase these parentheses. So in the numerator here, at first I'm going to have 8x squared plus 6x plus 22. Now let me switch to red, because this part I'm going to have to take this negative 2, mind you, negative 2, and I'm going to have to distribute that. Okay, now negative 2 times 3x squared, that's going to be negative 6x squared. Negative 2 times x is negative 2x. And negative 2 times 8 is negative 16. So we've got that. And then we still have all this divided by 2. Don't forget. Alright, but let's go ahead and combine our like terms now. So like terms, I've got 8x squared and minus 6x squared. Okay, so put those together and I get 2x squared. Alright, what's next? I've got 6x and minus 2x. So that's 4x. And then I've got positive 22 and negative 16. So that's 6. Okay, so we've combined all the like terms in the numerator. And all of this is still to be divided by 2. Okay, all along. So, if we take all of these and we divide by 2, then that's going to give us x squared plus 2x plus 3. So this would be an expression for the width. Okay, that was a next level problem. The struggle is real, you guys. X squared plus 2x plus 3, and that is D. All that for a multiple choice question. I'll tell you what. Wait, I want to circle it. Okay, this video is now 21 minutes long, so that's long enough for one video. And we're neatly at the end of the first page of this test and the end of the multiple choice. So I'm going to end this video right there. We will pick up the next video with the simplifying expressions on number 6. I'll catch you on that next video.